So we are going to learn about what is objects, and then we are going to make class, and we are going to understand about fields and some behavior methods, and then we are going to learn about the constructor. So we are going to learn about class. What is class? Now, I think you still remember one of the questions that I gave to you about cities or the coordinate. So let's say I have 6 points. So this is X, this is Y. And I want to have 6 points. The first point is 5.2. The second point is 3.5. So maybe 5.2. Oh, right. This is 4.2. Okay, anyway, yes, this is the point. 5.2, 3.5, 4.4, 1.2, 7.5, 3.0. Okay. And then let's say I want to know the center. The center point is 2.2. Now, I want you to write a program to calculate the distance between a point and the center. So for example, I have this point, 5.2. So is it possible to calculate the distance between 5.2 and 2.2? Yeah, it's possible. Now, how can we make the program? Based on your experience on the multi-dimensional list, the last chapter, we learned about the multi-dimensional list. If we learn with the multi-dimensional list, we can think about the coordinates. Let's say I want to know how many cities. So I can input the number of points, and then I will input X as one list, and then I have Y as another list. And then I would like to start from the I equals to 0 until the number of city count. And let's input the coordinates. So the X coordinate, it will be input, or I will append into the index 0. And then I will input the Y coordinates into the index 0 of this Y coordinate. And then I will go to the next value of I, and then I will input the X coordinate to the index number 1. I will input the index Y into the index number 1 of Y coordinates, and so on until we have the city count. Now I can represent the data something like this one. So in the point number 1, I have the X coordinates, and in the point number 1, I have the Y coordinates. So I have the point number 1 with X equals to 5 and Y equals to 2. If I use this kind of list, is it a good solution? Actually, yes, it is possible. You can make X, and then you can have the X coordinate is 5, 3, 4. So it means in this index 0, it is the x coordinate of point 1. In the index 1, the x coordinate, it is the x coordinate of point number 2. If it is index 2, then the variable x coordinates, it is the point number 3. It is possible. However, if we have x, we have y, and then we have z, then you will have another variable, z coordinates. If we have another variable, let's say in this city, I have the x coordinate, I have the y coordinate, and then I have another variable. For example, I want to know the weather, the temperature. Let's say I have another variable. I want to know the humidity. So there are many variables. So we call this is the best solution because of the parallel arrays. So 2 plus arrays with related data at the same index. So if you have another coordinate like z coordinate, so we have this list for index 0, 1, 2. We have this list for index 0, 1, 2. We have this list for index 0, 1, 2. So this is bad solution, because when you improve or when you increase the number of variables, you will also increase this list, and this is not good. We can use another way. So it can be easier to solve if there were such a thing as a point object. Okay, we call it point object. So let's say I have the point number 1. Okay, maybe the point number 1 is Seoul. So I can define what is the x and what is the y of Seoul city. I have another point number 2. And I have another x and y to define the point number 2. So that will be better. So the point means it will store the city x and y data, and we can compare distance between point. So it means if we have the x1, y1, we have x2, y2, we can easily compare the x1 and x2 data, and then we can compare easily the y1 and y2 data. Each point will have its own property. So if the point 1 have the x, y, and z, the point 2 have only x and y. That's the problem. And the overall program will be shorter and cleaner. So I need to have a kind of object so it can be clean. Clean, it means we can see in the table. Or we can say shorter. So I don't need to have many lists. So we come to the concept of class. What is class? A class is a program entity that represents either a program or module or a template for a new type of objects. The meaning by template means, let's say I have point. So I have already a template that every point should have x and y. So whenever I create a new object, there will be, if I create x and y, so I already make a template. If I have P1, then I can define x and y. If I have P2, then I have x and y. If I have another object P3, I can have x and y. So that's the meaning by template. A point class is a template for creating point objects. So the object means it is the entity that combines the state and the behavior. So we will learn what is the meaning by state and what is the meaning by behavior. So object-oriented programming means the programs that perform their behavior as interaction between objects. For example, as you might know that we have the point number 1. Let's say point number 1 x is 5. Point number 1 y is 2. Point number 2 we have 3 and 5. Point number 3 we have 4 and 4. Now we can say that we have one object and the name is point. Every point will contain x and y data. We call it fields. So every point have x and y. And then every point will contain behavior. The behavior we call it methods, or we know as function. And there will be a main program that will use the point objects. So you already know whenever I create functions, we have the main functions. So the main function will be the main program that will execute the point objects. In order to do this object-oriented programming, let me introduce the class diagram. What is class diagram? We call this is the class diagram. In this class diagram, there are 3 things: class name, field or data members, and methods or functions. So the upper part, we call it, this is the class name. The second part, we call it, this is the fields or data member. The third part, we call it, this is the methods or function. So there are 3 parts: class name, field or data members, and methods or function. So in general, I can say something like this. In general, I want to have a point 1. Okay, I have a point 1, and this point 1, the x is 5 and the y is -2. So I can define something like this. I have another point, point 2, and the point 2 is 0 and 0. So without defining any parameter, I can just set 0 and 0. I have the point 3, and the point 3 is 4.4. Then I have x is 4 and y is 4. So the data in every point, I know that there are x and y. So I can define x, this is the field name or the data, which is about the x coordinate. And then I have the data which is y, this is about the y coordinate. And I can define the methods or functions in the point objects. Let's say I want to set the location. So I have 2 parameters, x and y. So I can set the value of x, I can set the value of y. Translate dx dy means I can adjust the points x and y by the given amount. Maybe I want to shift 5 and -2. I want to shift maybe +3 and then this is minus 1. Then I can put the dx is 3 and dy is minus 1. Or I want to calculate the distance between points. So how far away the point is from point P. So I want to know the distance from point 1 to point P. Then I can make the method or functions to measure the distance. So this is the meaning by this class diagram. In this class diagram, we have 2 data members and we have 3 methods or functions. So in overall, we can have like this one. Every point will have a kind of template. Or I can say this is a kind of blueprint. So this point class will have the x and y, which is integer. And then I will have the behavior or the method set location. And then this is the integer, it is also integer. And I'm going to translate it, or I want to shift the x and y with a particular value, which is dx or dy. And I can say that I want to measure the distance between points. So I have the parameter. So if it is object number 1, I know that the data is x equals to 5, y equals to minus 2. If it is the point object number 2, then I can know that this is the x and y. If it is point object number 3, then I know that this is the x and this is the y. And all points will have the same behavior. So I can call the behavior and then I can run. The class or blueprints describe how to create objects. And each object contains its own data. This is the data. And its own methods. This is the methods. So we call this class diagram as the UML class diagram. UML. It is Unified Modeling Language. We have the class name, we have the data fields, and we have the constructor, and we have methods. For the object, we can also have another UML to indicate that this is the circle number 1, or this is the object number 1, and we can see that the radius is 1. This is circle 2, and the radius is 25. This is the circle 3, and the radius is 125. Okay, so we call this is the class diagram. Constructor, I will explain in the next lecture. Okay. Thank you for your question. So first, let's learn about fields. Now I'm going to make a new chapter. We have the chapter 07, we have the chapter 06. Now let me make a new chapter. I will make a new directory. Okay, please follow me. Okay, because if you miss one part, then you cannot continue to the next part. And if you have one error, and if you do not fix the error now, it will always error until the end. So let's make a new directory, and the directory name is chapter 08. Actually, the directory name can be anything. You can make your own directory name. Now let's make a new Python file. And the Python file name is point. Okay, so you already have point.py. Now, I would like to make a class. So I want to make a class point. And then I would like to define two data members, which is X and Y. Okay. Now you can see that it contains error. This error means they do not know what does it mean by X and what does it mean by Y. So if you look at this example, X equal to 0, then if you put like this one, Python will understand that this is a variable and this variable is integer. The same with Y. If I put X equals to 0, Y equals to 0, then Python understands that this data is using integer value. Now, I want to create a file. Then the file name is testpoint.py. Let's make another Python file. Let's make testpoint.py. You already know that if I have two files, if I have point and I have testpoint.py, and let's say I want to run the code in the point.py from testpoint.py. So I need to import. I can call from the point. So from the point.py, so point.py is here. I want to import. I want to import the point function, or I want to import the point class. That's the meaning. And in this test point, I need to define the main function or the function to execute the point.py. So I will make this one. The main function here, I would like to execute this main function and make a new object p1 or the point one, and the point one is using the template in the point. So this point means the point that you have here. So the template has two variables, X and Y. So if you do this one, print p1.x, and then you want to print p1.y. It means I want to call the data, which is X, from the point, and I want to call the data Y from the point. So let me just stop here. So I will call the main function. If I run this code, we will have 0 and 0, because in the point we have x start from 0 and x start from 0. Now let's say I change x equals to 1 and then y equals to 3. Then if I run this one, the result will be 1 and 3. So let me get back to 0. I can change the value of x in the P1, which is P1.x. I will change it into 3, for example. And then I want to change the P1.y, the variable y, I want to change it to 4. So let's print again. P1.x, P1.y. If I run this, so I can know that the original value is 0 and 0. After I change x equals to 3 and y equals to 4, then I can know the new value is 3 and 4. So here we have only the data from the object. Now, let's make another file, test.2. Test.02. In this test.02, I again want to import from point. So import the point, which is the point in the chapter 8. And then I make another function main. Let's create two objects. Okay, the object 1, I want to make P1. P1 is an object from point. And then let's make P2. It is also another object from point. So in this case, I have 2 points. If I want to print P1.x and then P1.y, and then I print P2.x and then P2.y, what is the result? Zero, 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 zero. Okay, because all values start with 0 from the point dot one. So I can make our own definition. Let's say I have the P1.x. Now I want to set up as 2. Okay, so let me just change this here. So the P1, I have the P1x and P1y, but I want to change the x equal to 2. For the P2, I want to change the P2.y equals to 4, let's say, and then I want to make some function P2.y multiply equal to 3. And then I want to make P2 equals to x is plus equal to 1. Is it possible? We call this is the variable. Y is the variable and P2 is the object. So the operation will be the same as any variable. So you can run. Sorry, I need to call the main. So we can see that the x, the first one, x becomes 2 and the y is 0. And then for the P2, P2y is started from 4 and then we want to multiply with 3. So it becomes 12. What about x? X will be added by 1. Then it is 1. Okay. So the object with the variable, we can also perform the operation, like what we did on the variable. So the explanation is like this one. We call it field or we call data members. It is a variable inside an object that is part of its state. Its object has its own copy of its field. So if I have P1, which is the point object, so the P1 dot x is started from 0, and then if I assign 2, then it will change to 2. So the way to modify and the way to access the field is using dot. So the variable means the object. Let's say this is the P1, and then we put the dot, and then we call the field name. Now we have the x, so we just put the P1 dot x. But what about if the field is name? So we need to call P1 dot name. Okay, it depends on the field. So this is a variable. You can define any name as long as the name is not using the Python keywords. So point.py. What is the point.py? So point.py, we call it as the class, and we have a client program. So the test point.py, it is the client program. We will call the point. We will call the point class from the point.py. So we call the point because this is the point name. We have P1 equals to point. So when we have this point, so we will call any value that has been defined here. So for example, now I have the point and then I have the x equals to 0 and y equals to 0. So we have x is 0 and y is 0. So if we call x equals to 7 and y equals to 2, then it means I have the first object, x is 7 and y is 2. I have the P2 and I have another point. If I call x is 4 and y is 3, then I have a new point which is x equals to 4 and y equals to 3. So usually when we do this kind of object-oriented programming, we will have two The first file is the class of objects, and the other files is the client program. We can have the object behavior. The object behavior means the function. Let's update the point.py. So I will open the point.py. We have class point, and then we define the data members. Okay. Or fields. And then after I have the data members and fields, I want to add function or function. Okay. So what is the function? I want to have one function that name is translate. So you know the function will start with def. And I am going to make the function name translate for creating any objects or for creating any class. You should have self. So it is the Python rule. Whenever you make a class, you need to have self. And after the self, you can define how many parameters or how many arguments you want to create. So let's say I have the dx and I have the dy. And I want to translate the original value to another value. So I can define self. The x, it means this is the value from the particular object, and I want to have the value is translated into another value which is plus by dx. So dx is this one. This x is the numbers that you can define in the function translate. And then, yeah, you can make the value y like this one. Self, oh, sorry, dy. So this is the same, like this one. Self.x equals to self.x plus dx. Or you have the self.y plus equal dy. So the translate method has two parameters. We have the x and dy. Self is a parameter that references the object itself. Using self, you can access the object members in the class definition. So you need to have the self in order to know what is the current value of that object. Now let's see. In the point test point 2, in the test point 2, we have P1 and we have P2. Now let's say I want to translate this P2. I want to translate the P2, so I can use the dot and then I call the function translate. What I'm going to do with this translate? So I have two parameters. You can see from here. So it mentioned that I have dx and dy. So I want to express, for example, maybe let me just make very huge value, 10 and 20. After I translate, so I want to know what is the current value, p2.x, p2.y. So you can see the object P1 has x and y 2, 0. P2 originally 0, 0. Now it has been changed to 12 for the y and then 1 for the x. But when I translate it, so the value will be added. So x will be added by 10 and y will be added by 20. So the result now becomes 11 and 32. So the meaning by translate is we want to update the current x. So x will be the current x plus the value in the dx. And y is the current y plus dy. My question is, what about the P1? Is it changed? P1 will have exactly the same value as this one because we do not translate it. Okay. So when we have object, we can have our own data. When we have another object, we can have our own data. So the data will be depending on its object. Okay, I guess because of the time, I will stop here. I will continue on Tuesday. And on Tuesday, I will now give you another learning check. Okay, so make sure that you review this material for the learning check. Thank you and have a good day.